Hello everyone, welcome to Shubhra Ranjan IS, myself Karuna Mishra, and I am here with another video on science and technology, and today we will be discussing the Aditya L1 mission. Now after Chandrayaan's success, ISRO has given another reason for the Indians to smile, and that is Aditya L1 mission. Now Aditya L1 mission is the first mission of India for Sun. India and ISRO have launched this mission to understand the sun, the surface of the sun better, the interaction of sun, the solar winds, etc. with earth, and how we can protect our equipments, etc. in space. Apart from that, another reason for the study of sun is understanding the solar system better, understanding the evolution of universe better, and understanding how the stars function, to expand our understanding as well as knowledge when it comes to how other different types of solar systems and galaxies, etc., they are functioning in the universe. So I have divided this particular lecture into these parts. First, we will understand what exactly is Aditya L1 mission. I have taken the content from ISRO's official website. If you want, you can also read from there. What is the aim for launching the mission? Then what are the payloads? Payloads kya hote? What are payloads? Payloads is, if the rocket is the transportation system, payloads are the passengers on it. So Aditya L1 mission basically is an observation mission in which you have put different equipments. ये जो different type के equipments हैं, कुछ cameras होंगे, कुछ spectrometers होंगे, etc. Their job, these equipments have the job of studying the sun and the different activities that take place on it for bettering our understanding about sun. Then what is the meaning of L1? यहाँ पर आदित्य के बाद एक जो term use हो रहा है, that is L1. So what do I understand by the term L1? Is there L2, L3, L4, L5, L6? Is there something like that? Then what is the significance of this mission and what is the future perspective when it comes to the missions to sun? Now without further ado, let us start. Now, understanding what is Aditya L1 mission and what ISRO had in mind while launching this mission. So, first of all, Aditya L1 is the first space-based mission or Indian mission to study the sun. So, the first thing that I have to keep in mind is that we have launched this mission to study sun. The spacecraft shall be placed in a halo orbit around the Lagrange point 1. So L1 here stands for Lagrange point. We will understand what is Lagrange point. So it will basically put the spacecraft or put the payloads in the L1 orbit or Lagrange 1 orbit of the Sun Earth system, which is about 1.5 million kilometers from the Earth. So first, what is this mission about? This is India's first space-based mission to study the sun. Second, where are you going to place this mission? We shall be placing this mission around 1.5 million kilometers away from the Earth at an orbit, a halo orbit, which is at Lagrange point 1 or L1. The satellite placed in the halo orbit around the L1 point has advantage of continuously viewing the sun without any eclipse. So why India chose to put this particular mission on Lagrange point 1 or on this at this particular orbit, so that the observation done by this particular mission will be without any eclipse on the sun. So it will be closer to the sun. Eclipse में क्या होता है? What happens during the eclipse? ग्रहण जिसको बोलते हैं. During the eclipse, it is as simple. If I don't know solar eclipse or lunar eclipse, etc., there are two bodies. There are two celestial bodies, and the third celestial body comes in between. It casts a shadow, and if I am standing here, I will not be able to observe this body completely, because this second body which is here, so if it is one body is here, one body is here, and another body comes in between due to revolution, etc., it will cast a shadow on this, and I will not be able to see it completely, and I can see only a portion of this particular body from here. So let us say this is Earth and this is Sun and this is Moon. So there is a casting of Moon on the Sun, and therefore you cannot see the Sun completely. So when the mission is parked, or if the mission is placed at Lagrange point 1, there will be no issue of such eclipsing, and the observation can be done throughout the year. or throughout the time. Now, this will provide a greater advantage of observing the solar activities and its effect on space weather in real time. So, first of all, why this mission is launched? To understand the activities on sun, and then understand that due to these activities, what are the effects on the space around the sun. I am talking about the solar system that we are living in and its effect in the other areas as well. The spacecraft shall carry 7 payloads to observe the photosphere, the chromosphere, and the outermost layer of the sun, the corona. So, this project is launched to study the sun. Which part of the sun? The outermost layer, which is also called as the photosphere, chromosphere. We will be understanding the parts of the sun as well in this video. So, we will be understanding basically the studies of the outer layer of the sun and its interaction with the space and how it affects the space weather. One technical point that we need to understand is what is Lagrange point and how does it have an advantage, and why this particular mission is launched on the L1 point. So, if I have to simplify it down, that what is the aim of this mission? The aim of this mission is to study the upper atmosphere of the sun, the solar upper atmosphere, to study the chromospheric and coronal heating. Corona is the outermost layer of the sun, and how the heating takes place and what are its effect. The physics of the partially ionized plasma. What is plasma, bache? Plasma is solid, liquid, gas. These are the 3 states we know, and the 4th state is the plasma state. The plasma state, most simple, is when you see a tube light. In the tube light there is a gas and you run the electricity, and because of the passing of electricity and the heat applied, the gas gets ionized and moves into the plasma state. So, जो आपकी ट्यूबलाइट में होता है, that is the plasma state of the gas. Similarly, when there is excessive heat applied to any gaseous particle, it might get changed to the plasma state, and in the sun you have the solar outer atmosphere of the sun is in the state of plasma. So, with Aditya L1 mission, I am trying to understand the plasma state of sun and the partially ionized plasma. What is coronal mass ejection? How does it get initiated? Very, very important for your examination, as well as understanding the activities that happens in the outer atmosphere, and then in the universe. Then what are solar flares, what are its effect, how it interacts with the Earth's atmosphere and magnetosphere, and the observation, observe the in situ particle and the plasma environment, as well as understanding the solar corona and heating mechanism. अब दिक्कत क्या है? This is how ISRO has given that these are the different aims of the mission. चंद्रयान में एंड आदित्य L1 मिशन में जो बहुत बड़ा डिफरेंस है कि वी हैव सम आइडिया अबाउट मून, बट व्हेन इट कम्स टू सन, मेजॉरिटी ऑफ द स्टूडेंट्स, ज्यादातर बच्चों को सन के पार्ट्स के बारे में पता नहीं होता. मेजॉरिटी ऑफ द स्टूडेंट्स डू नॉट नो व्हाट इज कोरोना, majority of the students do not know where is chromosphere, where is photosphere, what is coronal mass ejection, what are solar flares, what are sunspots, and ये सारे के सारे एक एक इंडिविजुअल टॉपिक आप प्रीलिम्स में या तो आ चुका है या आ सकता है. So let us understand first the mission, the payloads, and then we will understand in detail what are the different parts of the sun. Alright, so this was the aim of the mission. Now, after the aim of the mission, these are the different payloads which are present on the Aditya L1 mission. So, सबसे पहले आपने इन payloads को 2 parts में divide कर लेना है. You have to divide these payloads into 2 parts. First is the remote sensing payloads. Second is the in situ payloads. Remote sensing word कहीं भी आता है. Whenever you hear the word remote sensing का मतलब होता है फोटो खींचना. Right? This is what I say in the class also. Remote sensing is something is remote, that is at distance, and it is sensing something. That sensing can be either taking pictures of a place, or sensing different types of particles, or sensing different types of frequencies, or sensing different types of wavelengths and different material, etc. You can also sense the heat signatures. So, sensing, remote sensing satellites basically will do the corona imaging or spectroscopy, that is, it will take the images of the outer layer, the corona layer of the sun, which will be through WELK, VELC, VELC, which is visible emission line coronagraph. Then you have suit. Suit is another equipment which is, क्या होते हैं बेटा, पेलोड्स होते क्या हैं, डिफरेंट इक्विपमेंट्स होते हैं. These are different equipments which are placed on the different types of missions. आदित्य मिशन हो गया, चंद्रयान मिशन में जो पेलोड्स थे उनका काम अलग है. Again they will also do the detection and sensing etc. So ये payloads basically these are equipments, instruments. ये instruments check करेंगे आपका जो कोरोना वाला पार्ट है, coronal imaging, then solar ultraviolet imaging telescope. So there is a small telescope also which will make the assessment of photosphere, chromosphere etc. Then you have SOLEX, which is solar low energy X-ray spectrometer. What is the job? It is a soft X-ray spectrometer. Sun as a star. So it will basically study the sun as a star or the activities that take place in the star. मैम क्या मुझे ये सारे पेलोड्स को याद करना पड़ेगा? नहीं, सबको याद मत करो, but as an informed student go through it once and then make an analysis. Okay, what exactly is Aditya mission trying to do? I am more interested in this part rather than this part, for you to know that you should know that we are doing the imaging or we are studying the corona, we are studying the photosphere and chromosphere, we are studying the activities of sun as a star, we are using L1 OS, that is high energy L1 orbiting X-ray spectrometer, we are using X-rays to study sun as a star. Then plasma analyzer or PAPA, plasma analyzer package for Aditya, it basically is going to study the particles which are present in the wind or the solar wind and how it interacts with not just Earth's atmosphere or magnetosphere but other planets as well. Similarly, you have ASPECS, which is Aditya Solar Wind Particle Experiment, which is again going to analyze the protons or the heavier ions and the particles in the solar wind. So these are the different types of payloads. Some are remote sensing, other are in situ. What do you understand by in situ? जिस जगह पे है वहीं. In situ आप environment में, you study in environment. In situ conservation, ex situ conservation. In situ conservation is protecting the tiger in its own habitat. तो in situ word कहीं पे भी आता है. In situ means at that place. So you are studying the solar wind near the sun to analyze what is the intensity, what is the interaction, what are the properties. So these are the different. Then you have the advanced triaxial high resolution digital magnetometer also, which is going to study the magnetic field. So this is how the Aditya mission looks like, Aditya L1 looks like, and these are the different payloads. As you can see, you have STOWED, you have VELC, you have SUIT, you have PAPA, you have HE-L1 OS, then you have Swiss steps etc. These are the payloads. What you need to remember? You need to remember this part. Where can you find this content? If you go to ISRO's site, you will find a link to Aditya L1 and you can find this exact data over there. Now, let us understand the basic concepts. We understood what is the aim of the mission. We understood what are the payloads which are part of Aditya L1 mission. Now, let us understand what is L1, what is Lagrange points. And then we'll understand the structure of the sun as well. अब क्या होते हैं भाई Lagrange points? What are Lagrange points? Lagrange points को बोला जाता है the parking spaces और parking places in the space. क्या मतलब हुआ मैम parking places का? पार्क थोड़ी कर रहे हैं हम किसी चीज को, हम पार्क ही तो कर रहे हैं. अब देखिए, you have, this is moon, this is earth, right, and this is sun. These are the three celestial bodies that I am interested in when I am sending any mission towards sun. Why? Because moon orbits around the earth and then earth orbits around the sun. This is where the orbit L1 is. L1, L2, L3, L4, L5, these are such 5 points or 5 areas in the space which is corresponding to earth and sun, where the total gravitational force is equal to the centrifugal force, and the placement of any mission or any satellite or any observation equipment, if I put it here, it will not feel the gravitational force by any of these planets and it will remain parked there. तो यहाँ पर the forces they cancel out each other. The forces they cancel out each other, therefore they are called as parking places. I'll repeat, these are those areas. Lagrange point is a location in space where the combined gravitational forces of two large bodies. Which body am I talking about? The Earth and Sun. So here I'm talking about the Earth and Sun or the Earth and Moon, where the combined gravitational force equals to the centrifugal force felt by a smaller body, and here the smaller body is Aditya L1 mission. Centrifugal force क्या होता था? Centrifugal force, if you are not from science background, but if you remember, बचपन में बच्चे फुगड़ी खेलते हैं. फुगड़ी क्या होता है? दोनों हाथ पकड़ के they rotate around. So the force, वो जो circular force होता है, that is called as centrifugal force, right? और when you tie एक string में, in a string, if you tie a stone and you rotate it, this force is centrifugal force. So here the centrifugal force is always felt by the object which is moving around, right? तो यहाँ पर of course this mission is going to observe the sun, so there can be an element of moving around the sun or orbiting the sun also. It will feel the force towards the sun because sun has a higher gravity, but here the centrifugal force will be equated with the gravitational force and you can park the mission in such places and it will not be disturbed by either of the two forces. तो इसका एक सिंपल भाषा में, जहाँ पर किसी भी बड़े ऑब्जेक्ट की ग्रेविटी फील नहीं हो, where the object placed or the mission placed or the satellite placed will not feel the gravitational push or pull of either of the bodies. So that is a Lagrange point. The interaction of the forces creates a point of equilibrium where the spacecraft may be parked to make the observation. So what is parked? That it is just staying there stationary without getting disturbed and it can do the observation. Hence L1. So L1 stands for Lagrange point 1. It stands for Lagrange point 1. So this is L1. Similarly, you have 5 such points between Earth and Sun where you can place the different projects for making the observation. So these are the different projects that have been placed at different Lagrange points. At L1 you already have SOHO, which stands for Solar and Heliospheric Observatory. Then you have another project WIND. Then you have ACE, which is Advanced Composition Explorer. At Lagrange point 2 you have Herschel Space Observatory, you have Planck Observatory, you have Wilkinson's anisotropy probe, etc. So Aditya L1 mission is the first mission of India, but it is not the first mission to moon as of now. There are many missions and they choose to place the missions at Lagrange points, which are the parking spaces where the observatory does not get disturbed. So this is understanding what is Lagrange points. Now let us go to further basics in understanding what is the structure of sun. So for understanding the structure of sun, you need to understand what is coronal mass ejection and you need to understand what are solar flares. But before this, let us understand what is the basic structure of the sun. Now, this is the core of the sun. I am talking about this region. This is the core of the sun. What is the source of energy of sun or any star? The source of energy is nuclear fusion. Nuclear fusion is the source of energy, that is where the isotopes of hydrogen, I am talking about deuterium and tritium, they combine to form helium. This reaction is the nuclear fusion reaction and they combine to form helium and the energy is released. So this is the source of energy. So where the energy is generated? The energy is generated in the core. this is where the nuclear fusion takes place. So sun's core is where the energy is generated by the thermonuclear reactions, creating extreme temperature deep within the sun. So here the temperature is extremely high. The temperature here is extremely high. Now from the core, the temperature starts moving to the outer surface, and this zone is called as radiative zone. This zone is called the radiative zone, that is, the energy moves slowly outward, taking more than 170,000 years to radiate through the layers of the sun. From core to the outer surface, it takes this energy 170,000 years to reach the surface of sun, and from sun then the energy reaches the different planets including Earth. So here it takes 170,000 years to radiate through the layers of the sun, and this zone is called the radiative zone. So what have we understood so far? There is a core where nuclear fusion takes place, where the energy is generated. From here the energy moves outward, and this zone is called as the radiative zone, where the energy is moving outward. Let us move to the area which is chromosphere, photosphere, etc. So now you have the chromosphere. जो आपका आदित्य L1 mission में you have the payloads which is going to study the chromosphere. So what exactly are all right. So what is chromosphere? Chromosphere is a relatively thin layer. It is a relatively thin layer of the sun, and it is called the chromosphere. It is sculpted by the magnetic field lines that restrain the electrically charged solar plasma. So basically chromosphere, that is the outer layer, it makes sure that the sun's magnetism, it does not allow the solar plasma or this high energy particles to simply distribute throughout the area around it. So it keeps it intact. The gravity, the magnetic field keeps the solar plasma more towards the sun, and occasionally the larger plasma features, they are removed from the sun, and this ejection is called as coronal mass ejection. This ejection is called as solar flares, etc. So what is the role of chromosphere? Chromosphere is that region which is dominated by the magnetic field lines of the sun, which makes sure that the solar plasma or the heat remains closer to the sun. But then there is sometimes the area where the buildup of heat takes place. The buildup of heat takes place and the plasma starts moving outside. So for example, coronal streamers. What is coronal streamers? The outward flowing plasma of the corona, which is shaped by the magnetic field, it is tapered into the forms of coronal streamers which extend to millions of kilometers into the space. So sabse pehle there was a core where the nuclear fusion is taking place, where the energy is released. From the core, energy reaches to the radiative zone or radiative zone, where the energy movement takes place. Now the energy is moving towards the outer areas. Now I am talking about chromosphere. In the chromosphere, the magnetism of the sun keeps the plasma closer to the sun, but sometimes or majority of the times the plasma is removed in the form of coronal streamers along the magnetic lines, and it is then released into the outer space. More violent type of release is in the form of coronal mass ejection or solar flares, which also we will see. But before that, let us understand what is corona and how corona is formed. तो corona, basically corona का मतलब क्या होता है? कोरोना वायरस भी आया था. Corona means crown. So when you look at sun, there is a halo. हैलो वो जो गोल्डन कलर का एक आपका सर्कुलर जो क्राउन टाइप का शेप बनता है, दैट इज कॉल्ड एज कोरोना. दैट इज बिकॉज ऑफ दिस लेयर, दिस हीटेड लेयर, राइट? हाउ डू यू get this heat to the outer surface? So just like Earth's interior, even in the sun's interior, the heat which reaches the outer layers, it is then moved into this circular convective zone, right? Same thing happens with the earth also, that the heat in the interiors of the earth, it moves in the convective form, and then you have the divergent or the convergent boundaries accordingly. So in the convective zone or convection zone, the energy continues to move towards the surface through the convection currents of heated and cooled gas in the convective zones, and that is how the heat, it gets to the outer surface. So heat is generated into the core, then moves into the radiative zones, and then gets transported through the outer surface. And now let us understand what is corona. If I minimize this, as you can see, this glowy surface, this glow that you can see around the sun, this is called as corona. This is called as corona. So what exactly is corona? Corona is when these ionized high energy heated particles, these ionized elements within the corona glow in the X-ray and extreme ultraviolet wavelengths, and this is the most heated part of the sun. Corona is the most heated part of the sun. This is where the maximum heat is felt, because the entire heat that is generated in the core tries to reach to the surface, where the gases, they get converted into the plasma form, and this plasma is then emitted. The high energies are emitted, since the photosphere is quite dim in these wavelengths, through corona. So photosphere is the visible layer of the sun, and then through corona, that is the glowy part, the crown part of the sun, then this plasma is released into the outer atmosphere. There was another concept when we were studying the different payloads, which was coronal mass ejection and solar flare. Now what is coronal mass ejection? This is coronal mass ejection. It is like a cloud, high energy cloud of plasma. When there is so much heat which is accumulated, it is released in the form of this high energy cloud, and this is called as the coronal mass ejection, right? So coronal mass ejections are the large clouds of solar plasma, and it then interacts with the magnetic field of the earth, it interacts with the satellites, it interacts with the communication networks, and it can cause severe damage to the communication network. A little less violent but enough to damage the infrastructure is solar flare. As you can see, solar flare is sudden release of energy, and whatever direction this release of energy is, it will interact with the atmosphere, it will interact with the magnetosphere also of that particular it can be a moon, it can be a planet like earth, etc. So solar flare are also the energetic bursts of light, like the energy is bursting out in the space of the light and particles, which is triggered by the release of magnetic energy of the sun, and it reaches far areas, earth, etc. also, and then it causes interaction and even damage to the infrastructure on earth. So in today's class, we understood, most importantly, what exactly is Aditya L1 mission. We understood what is Aditya L1 mission. We understood the various payloads that were the remote sensing payloads and the in-situ payloads. Then we understood what is L1 or the Lagrange points. We understood the structure of the sun, and now we need to understand the significance of the mission and future perspective. Why India has launched Aditya L1 mission? Because India wants to understand the outer layer of the sun. Why India wants to understand outer layer of the sun and the activities that take place? Because that is where the interaction with the infrastructure, such as satellite infrastructure or communication infrastructure, takes place. Solar flare in the form of solar flare, coronal mass ejection, etc. Also, India wants to understand how the stars function, because we want to expand our understanding of the universe. What is the future perspective? Future perspective is that we will use our knowledge of the functioning of the star and how the sun behaves in order to launch more missions that will be studying not just the stars which is of our solar system, but the other stars as well. So this was my attempt in short to teach you what is Aditya mission and what are the important concepts which are around the Aditya L1 mission. For more such videos, keep tuned in. You will get videos which are on the basic understanding of the topics of science and technology. Thank you so much. Have a nice day.